What is up, Math Nation? Mr. Cornell coming at you here, loose, ready to go after a quick yoga sesh with the kids before they went to bed. Hope you guys are feeling good yourself. At this point, we all know we are not going to be going back to school, so we're going to try and make the best of what we got. So we're going to go over some stuff here with graphing sines and cosine functions with period and frequency. We're not going to be using the calculator today, which you'll figure out why. You might be mad, but in the end you'll kind of see the reason why you're not going to have a calculator necessary. All right, so here we go. So in the equations, a sine x and a cosine x, well, what does the a represent? Well, we went over that in the last lesson, and the a is going to represent our amplitude. And that's the height, the maximum or the minimum that the graph will go as it's being graphed from 0 to wherever, 2 pi or whatever the case might be. So it says, what is the amplitude of a sinusoidal curve? So remember, that could mean a sine curve or a cosine curve. And the amplitude, or its height, is the absolute value of the A, which is the amplitude, which in this case was here. So it's important to realize, so if I told you that the amplitude was 3, okay, that means it was going as high as 3 and as low as negative 3. All right, so kind of keep that in mind because it might come in handy a little bit later on. So that's what we're going to take a look at today, is we're going to explore a sine bx and a sine cosine bx, and we're going to start looking at what happens if I get a number inside the parentheses with the x. So here we go. Below is a graph of one cycle of a sine x. So I know that it's a one cycle because I know a sine. Okay, it's going to start here. It's going to complete up one maximum, down one minimum, and back down to here. And that's one cycle. And in this case, that cycle went from 0 to 2 pi. Now, this is a sine, y equals sine x. So if I kind of throw in our what we have up there, the amplitude here was 1, okay, because there's that imaginary 1 here. And then the b value is 1 also because there's an imaginary 1 next to the x. So there you go. There is where the b falls into place right there. All right, so now let's take a look at another one to see if this is all going to start to make sense. So now we have two more sine curves. One is going to be amplitude of 1 sine b value of 2x, amplitude of 1 b value of 1/2 x. So here we have the graph here, and if you look, it goes down, up, down, back here, up, down, and back here. Okay, so what happened here is it was what we would call one cycle, okay, because the sine curve goes up, down, and back to where it began. So that's one cycle there, and then it goes up, down, back to there, and then that's another cycle there. So if you look at it, 1 and 1, we completed 2 cycles. Okay, 0 to 2 pi, right? I don't know why it keeps sticking on me. Stop it. Okay. Here we go. Here, from 0 to 2 pi, because that's what we've been looking at, it goes up, and then it stops right there. To complete a sine curve, to go down and back up, it took all the way to 4 pi to get there. So if you think about it, from 0 to 2 pi, it only completed half of its cycle, okay? The other half had to get completed by going another 2 pi. And that's why from 2 pi to 2 pi, that's why I got 4 pi there. And then here was another 2 pi. So that's kind of our introduction there to where what that b value could represent for us. All right. So it's saying as the b value changes, what happens to the sine curve? Okay, so remember, again, this is the most important part. Remember, a sine curve has to go complete this, okay? So we looked at what happened when there were 2 sine curves between 0 and 2 pi, and what happens when there was only half of a sine curve between 0 and 2 pi. Well, that b value is representing a horizontal dilation. And if you remember, a dilation, okay, could stretch or shrink things, okay? So it's a horizontal stretch or shrink. Too many C's here. Okay, horizontal stretch or shrink. So between 0 to 2 pi, how many cycles of a sine curve appear for each graph? What do you notice about this number compared to the value of b? Okay, so we've basically done, and I'll kind of just map it out for us, we've done 3 graphs so far since I started talking. We did sine x, we did sine 2x, and we did sine 1/2 x. Well, it says how many cycles? That's the question. Here there was 1 cycle, okay, an up, a down, and up. Here, okay, that was this guy up here. That one had 2 cycles, and then the 1/2, that one had a half of a cycle. So it says, well, what do we notice about the number compared to the value of b? Well, that b value is telling us, okay, how many cycles appeared between 0 and 2 pi, okay? So this was all, okay, that's important, all between 0 and 2 pi. Okay, so over here, just don't get too confused, it took 4 pi to complete the cycle, but it was only a half of a cycle between 0 and 2 pi. Alright, let's keep going. So that's going to kind of lead us into what we're going to look at now, which is we're going to get some names to things of frequency and period of these sine and cosine curves. So the parent functions for graph for sine and cosine have a period between 0 and 2 pi. Okay, so again, between 0 and 2 pi is what we call 1 cycle. So by definition, the period of a sinusoidal curve is the length of 1 complete cycle. The length of 1 complete cycle. Okay, so here we have our sine and cosine, so we'll start to introduce that guy. Okay, this was important. We looked at those in previous lessons, the critical values, and remember those came at 0, they came at pi over 2, pi, 3 pi over 2, and 2 pi. And you notice here it was 0, 1, 0, -1, and 0. Okay, and those are those 5. 1, 2, 3, 4, 5. That was 1 cycle of a sine curve between 0 and 2 pi. For a cosine curve, it's 1, 0, -1, 0, and 1. And that's that right there. Okay, so those are really good ones to kind of keep in your back pocket to memorize and having our shape here. Sorry my phone keeps going off. I can't help that I'm popular. Let's tell everybody to leave me alone. Mute. Oh, iPhones. Okay. So let's keep going. So if the value of b changes, then the number of cycles between 0 and 2 pi will change, okay? So by definition, the frequency of a sinusoidal curve, remember they're talking about a sine and a cosine, is the number of cycles from 0 to 2 pi. Number of cycles between 0 and 2 pi. And that happened at the b value. So b is going to be the frequency. And just to throw that out, again this we're using sine, it could say cosine too. bx, okay, and that's kind of right there. So since the sine and cosine functions have a period of 2 pi, the function a sine bx or a cosine bx complete one period as bx goes from 0 to 2 pi. Okay, so here we go again. So we have a period definition, okay? In other words, to find the period of a sine or cosine curve, divide by 2 pi, okay? So let's read this again to make sure we're good. since the sine and cosine function have a period of 2 pi, then those functions complete one period as bx varies. Okay, so we're trying to figure out how long it takes to complete one cycle or a period. So that's going to be 2 pi, because that again, that's one period divided by our frequency, how many times that takes. And then this would tell me the length of the curve. And as we start doing some definitions, some examples, and you can physically see it, it gets a little bit easier to understand. Okay, so here are two graphs. Okay, state the frequency and period of each sinusoidal curve without looking at the graphs. Okay, so that's kind of taking a look at this guy here. So it wants the frequency and the period. So remember, on our curves here, right? This is our amplitude, and then this, that right there, that's our frequency. So what is the number with the x? That's going to tell us our frequency, which is 2. Now to figure out the period, we are going to do 2 pi divided by 2, and then that's going to give us pi. So again, well, what does period mean? Okay, period is, okay, for this one was pi. So it took from 0 to pi to complete one cycle. Okay, and that's what a definition is. How long did it take to complete one cycle of either a sine or a cosine? And then frequency is how many cycles were completed between 0 and 2 pi. Okay, so rewind and listen to me and do that again, and it'll sound like it's supposed to sound. All right, so here we go. Sine 1/2 x. So the number with the x is going to represent our frequency, which in this case is 1/2. Now to figure out the period, okay, what we're going to do is we're going to do 2 pi divided by b, which is 2 pi divided by 1/2. And if you're going to do the math, that's going to give you 4 pi. So again, from here to here completed a half of a cycle of a sine. Okay, that's your frequency. Then, how long did it take to complete that one cycle or a period? Well, that took a full 4 pi to complete your one cycle. Okay. All right. Okay, so if you just got lost in all of that, then just go watch it again. Okay. State the amplitude, period, n, which is 2 pi divided by b, and the frequency, which is b, of the sinusoidal curves, which remember are a sine or cosine, bx. Okay, so here, remember the amplitude is the absolute value, so the absolute value of 3 is 3. The frequency, that is the number next to the x, that is going to be 1. To find the period, we are going to do 2 pi divided by b, which is 2 pi divided by 1, which is 2 pi. Okay, so there you go. Hit pause, try b, try c. All right, here we go. B has an imaginary 1 in front of this, in front of that cosine. So the amplitude is the absolute value of -1, so the amplitude was 1. The frequency was 1/3, and the period, the formula is 2 pi over b, which is 2 pi divided by 1/3. Now, if you're using a calculator and you're doing 2 divided by 1 divided by 3, don't put the pi in there. Or if you remember from previous lessons, when you're doing fraction over fraction, flip it. So you're basically doing 2 times 3 over 1. And that's going to give you 6 pi. Okay, so for that, again, period is how long did it take to complete one cycle? It took 6 pi to complete one cycle. All right, and then the last one, our frequency was the absolute value of 1/2. So that means that this was our amplitude, our frequency is 3, and our period is 2 pi divided by 3, and that simplifies to the same thing. It's not going to change. It's going to stay as 2 pi over 3. All right, so there is kind of looking at it. If I give you a formula, kind of tell me what the amplitude, frequency, and period is from there. All right, so here's a similar example where it gets a little twist to it. So all I want is your period. So to find period, remember you're doing 2 pi divided by b. Now our b value, or our number with the x, is pi over 2. So this would look like 2 pi divided by pi over 2. Now I just said before, because we're not really throwing this in the calculator, to do a fraction over a fraction, you're going to flip or take a reciprocal of this, which becomes 2 pi. This cancels with this. 2 times 2, 4. You could throw it in your calculator. And again, for those of us getting crazy with calculators, make sure you throw this in the parentheses on the bottom. But you got to be careful, because on the top it really won't work, because it'll give you a decimal answer, because it won't leave the pi. All right, so there you go for example 3. Example 4. Again, it's the same thing, except it's backwards here, and it's making sure, do you understand what amplitude is? Do you understand what frequency is? Do you understand what period is? And some of you, or most of you, are probably saying, no, I still have absolutely no idea what you're talking about. Well, I'll just keep going pretending like you do. All right, so here we go. So for this first one, okay, I'll look at the amplitude. That's the easy one. That's how high did it go? Well, if I'm looking at this one, it went as high and as low as 2. So the amplitude is 2. All right, now, frequency, okay, so we're looking at between 0 and 2 pi. Well, here's my sine curve. It went down, it went up, it went down. So it was able to complete one of its cycles, so its frequency would be 1. And now the period, which would be 2 pi over b, or how long did it take? Well, we just looked at it. I just defined it. It took 1 cycle, so the period was 2 pi. All right, now let's take a look at this one. The amplitude, that's the easy one. How high did it go? It's right here between 0 and 1, so that's going to be 1/2. The frequency, so between 0 and 2 pi, how many times did I see that down, up, down motion, right? As I keep saying it, down, up, down, right here, boom, 1 time. There it goes again. Okay, so if I try to make that a color, that's 1 cycle. Okay, then here it goes again. That's another cycle. So it was able to complete 2 cycles in that time period. So we're going to say that the frequency, how many times did it get completed, was 2. Now to figure out its period, 2 pi over b, or 2 pi over 2, well, pi, okay? And without using the formula, it completed 1 cycle from there to there. And there, right there, that's at pi, and that was that answer there. So without going through the formula. And the last one here, okay, my highest and my lowest spot right there. So my amplitude is going to be 2. Now this is where it gets a little bit tricky, because you didn't really see it do that up, down, right? You didn't really see that. You only saw it just do this between 0 and 2 pi. Well, what is that? That's half of a cycle, right? So the frequency was 1/2. Now the period, well, if it took half to go to 2 pi, how much more do I need? Well, I need another 2 pi. So then that means that the period would be 4 pi. And if you don't believe me, then throw it into the formula we did a few times. All right. So in summary, what did we look at so far? So identifying, graphing them, and again, have these critical values in mind in your back pocket. Know when to use for the sine and the cosine, because it'll just be faster when you're not using your calculator. So for sine, it was 0, 1, 0, -1, 0. That's that up, hits it again, down, right back there. Okay, so if we draw that quick, it looks like that, right? Now the cosine one, that's the one that starts up here and then it does this motion here. So there are all my critical values right there. Those critical values are at 1, 0, -1, 0, +1. Now, here we go. Remember to multiply all critical values by your amplitude. So if this one had an amplitude of 2, okay, then it would go 2, 0, -2, 0, 2. Okay? Multiply critical values by that, right? So graphing one cycle of the wave by using the value of the period and the key points of the curve. So one cycle of a wave by using the value of the period and the key points, okay? So that's why it's important to kind of do this, because that would be graphing without a calculator. And you're going to say, well, when am I going to graph without a calculator? Well, give me a second, I'll get there. And then it's, again, we're going to pass through all 5 values and use the given interval. So, well, where do they want you to graph it? Do they want you to graph it from 0 to pi, 0 to 2 pi, or 4 pi? All right, so let's look at this. So now, I agree. Yes, you can just throw this into your calculator. But let's not do that now for reasons you'll see in a minute. So graph 2 cycles of the negative cosine x between 0 and 2 pi. So now, why can't you just throw this into your calculator? Because if you threw this into your calculator, you're only telling it to graph one frequency of 1 cycle between 0 and 2 pi. So again, have that idea that a cosine curve looks like this, right? So if you're throwing a negative, that means you're going to be throwing it upside down, right? So that's what the negative means. Now the question says, because again this is 2 pi, well the question says, well, I want you to do 2 cycles. So I want you to complete this between 0 and 2 pi. So remember, the halfway point is pi. So really what you're going to do is you're going to kind of try to go down, up, down, okay, or up, down, right? Then you're going to do it again, up, down. So that is what this question is looking for. And that's why it's important to have your critical values memorized, okay? So our critical values for a cosine were 1, 0, that's not a negative, get that out of there, okay? 1, 0, -1, 0, +1. We said before, multiply those critical values by your amplitude, and in this case was -1. So it's -1, 0, +1, 0, -1. Now I want you to complete this, but you got to now take it in half. So the period, okay, would be 2 pi over b, which in this case, 2 cycles, 2 pi over 2, so you're going to get pi. So you, like we were showing before, I need to get 1 cycle between 0 and pi. So let's graph this. So here's what we're looking in our positive space, right? So I'll skip a couple and we'll go 1. I do 1, 2, 3, and then that's -1, just to kind of exaggerate it a little. So here's at 0. I really don't want all that dot there, right? So I got to get pi over 2, 1, 2, 1, 2, and it's pi, 1, 2. Then it's 3 pi over 2, 1, 2, and then it's 2 pi. All right, so that's what the graph looks like. There's our graph. Now we're going to start. Our amplitude started at -1. Let's make this a different color. So our amplitude started at -1, our critical value. Now from there to there, it's going to go up to 1. So watch what I do. Watch me go. That right there is 1 cycle of a cosine function. Okay? Then I'm just going to repeat that again. Up, turn around, back down, and there right there, that completed 2 cycles of a negative cosine function. All right? Let's go again now. Let's try this one. Now this one's going from 0 to 4 pi, so it's going to be a little bit bigger. And it's going to be 3 sine theta over 2, Well, remember that the theta could always be an x, so it could be over x over 2. They're just using it as theta. So the amplitude here is 3. Now it's a sine. What are our critical values of a sine? 0, 1, 0, -1, and 0. So remember, we have to multiply that by there. So it's 0, 3, 0, -3, 0. All right. Now let's figure out, well, when did one cycle get completed? So our frequency was 1/2, right? Because it's x over 2, so it's 1 over 2. So the period of 2 pi over b, 2 pi over 1/2 is 4 pi. So it took a full 4 pi to complete this, okay, these critical values. All right, so let's do it again. So we'll make it here, 1 and 2. We're looking at a positive space. I forget, our amplitude here was 3. So we'll skip 1, do 1, skip 1, do 2, skip 1, do 3, skip 1, -1, skip 1, -2, skip 1, -3. All right, so now let's mark out our radian degree measure here. So right here, skip 1, pi over 2, skip 1, here's pi, skip 1, 3 pi over 2, skip 1, there's 2 pi. Okay, and then what was that? 1, 2, 3, 4, 5, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8, right? So then there's going to be 4 pi, and then where's 3 pi? All right, so basically from 0 to 2 pi was 8 spaces, so each 1, 2, 3, 4 was a pi, 1, 2, 3, 4, 2 pi, 1, 2, 3, 4, that's 3 pi, 1, 2, 3, 4, there's 4 pi. All right, so let's complete one cycle of a sine curve from 0 to 4 pi. Okay, so we know one cycle of a sine curve has to look like this, right? So there. Now when I hit 2 pi, that's going to be half, and when I hit 4, that's going to be the full. So that means right there, at pi, I'll go up to 3. At 3 pi, I'll go down to 3. So here I'm going, there's half of the cycle, and then there's the rest of the cycle. Okay? And that's how you complete one cycle between 0 and 4 pi of that curve. All right? Almost there. Almost there. Identify key points. So now let's graph sine and cosines. Why this whole time did I not use a calculator? Because of these examples right here. Okay? What happens if I didn't actually give you the function and I just gave you, say, the amplitude, the frequency, and the period? So identify our key points for sine and cosine. Those are our critical values. The properties of the graph, okay, our amplitude, our frequency. Graph one cycle of the wave by using the value of the period, using those critical values, and use the given interval and directions to determine how many cycles you will need to do. All right. So this first one, the interval is going to be between 0 and 2 pi. So again, we're going to go here. So I'll skip 1, pi over 2. Skip 1, there's pi. Skip 1, there's 3 pi over 2. Skip 1, there's 2 pi. So that's the interval they're telling me. So it's going to be a sine function. It's going to go up to 3, and it's going to have a period of pi over 2. So that means it's going to, again, here's period again. Has to complete, okay, right there, complete one cycle. Okay, you have to complete one cycle between 0 and pi over 2. So that's for sine, up, down, finish, okay? So if we're going to go through that box up there, right? So for a sine curve, our critical values are 0, 1, 0, -1, and 0. it says that our amplitude was 3, so we got to multiply all of these guys by 3. So that means we're going to get 0, 3, -3, and 0. Now, it has to do this from 0, and then it's going to complete that all the way to 2 pi. Okay? So let's try to figure this one out. Here's 0, here's 2 pi. You have to complete 3, 0, -3, 0 between that area, right? But you're going to, between 0 and pi over 2, you have to complete one cycle. So let's do 1, 2, 3. 1, 2, 3. -1, -2, -3. There and there. So this one's going to be a little bit tight. So I have to go down, up, and down before I get, or up, down, and up before I get there. So I'm going to go up, 3, down, and then, oh, I got to go all the way down to 3, back up. Okay? So that's pi over 2. Okay? I completed one cycle. So then you got to do it again, back to pi. Then you're going to do it again, back to 3 pi over 2, and again. So I got to go up to 3, down, complete the cycle. Up to 3, down, complete the cycle. Now again, these have to be all here. Up, down, back up. That's a rough one. Very tight. Okay, so, but again, this is telling you how many times you have to do it. This is telling you how high you have to go. And these guys are telling you how many times to hit there. Okay? All right, last one, and we can all go home. Oh, wait, I have to tell you this. Remember, amplitude is absolute value. So if I'm telling you the amplitude was 3, okay, let's say that this whole thing would have been 3 sine pi over 2x, right? It could have said -3 sine pi over 2x, which means that this just would have went the other way. It would have looked exactly the same. So you don't know which one that they were saying, whether it was a 3 sine or a -3 sine. We just went with the 3 sine to make things easier. All right, now why was that important? Because here they're telling you. So on the set of axes below, graph 2 cycles of a cosine function with an amplitude of 2 and a period of pi. So that's how long it takes to complete one cycle. And it has to pass through this point 0, -2, right? So we know our amplitude was 2, right? So it's going to go up as high as 2 and down as -2. So skip 1, pi over 2, skip 1, pi, skip 1, 3 pi over 2, skip 1, 2 pi. So you're going to complete, now this is a cosine function, right? So again, that's why it's important to kind of know that's what a cosine function looks like, right? You have to complete one of these shapes from 0 to pi. Has to look like that. It's going to go this high, okay? So technically, I guess you could say that that number is 2, right? And then when as low as -2. But now, like, here's your twist to that question. Your twist to that question is that it has to pass through that point. Well, where is that point? I got to get rid of those other ones. Oh, it's all ruined. No, we'll pretend they're not there. All right, so where is that point? That point is there. So if you have to pass the graph through this point, well, that's the beginning. That's where you're going to start. So that's how in this particular case, when they were telling you that the amplitude was 2, well, if it's going to look like this, well, in this case, now it's going to do this because it has to pass through that point of 0, -2. So here is one cycle or a period of pi. Now they wanted 2 cycles, so I'm just going to repeat that. It's going to go up to 2. There you go. Down, up, down, and there you go. So now I completed 2 cycles between 0 and 2 pi with a period of pi and an amplitude of 2. Take it for what it's worth. you have any more questions, send me a message, leave a comment. If you loved it, leave a comment, like, subscribe, post notifications, all that awesome fun stuff. Have a great day, everybody.